What if Earth's oceans suddenly boiled away? How hot would it need to get, and what would happen to life on our planet? Well, you've stumbled onto one of the most terrifying climate scenarios imaginable. We're not talking about a gentle warming trend here. We're talking about temperatures so extreme they would literally cook our planet alive and transform Earth into a hellscape that makes Venus look like a tropical vacation. Let's start with the obvious question. How hot would our oceans need to get before they start boiling? You might think the answer is simple, just heat water to 100 degrees Celsius, right? Unfortunately, it's not that straightforward. Ocean water isn't pure water. It's loaded with salt, and salt changes everything. Pure water boils at exactly 100 degrees Celsius under normal atmospheric pressure at sea level. But seawater, that's a different story entirely. With all that dissolved salt acting like tiny anchors holding water molecules together, ocean water doesn't start boiling until it reaches about 108.7 degrees Celsius. That might not sound like much of a difference, but when you're talking about boiling away 1.3 billion cubic kilometers of water, that's the entire volume of Earth's oceans. Every degree matters enormously. Here's where things get really interesting, and by interesting, I mean absolutely catastrophic. As the oceans start to boil away, the remaining water becomes saltier and saltier. It's like reducing a sauce on your stove, except instead of making dinner, you're destroying all life on Earth. So you'd need increasingly hotter temperatures to keep the process going. But that's just the beginning of our problems. As massive amounts of water vapor start flooding into the atmosphere, we trigger what scientists call a runaway greenhouse effect. Think of it as the ultimate climate feedback loop from hell. Water vapor is itself a greenhouse gas, and as more and more of it accumulates in our atmosphere, it traps more heat from the sunday. This trapped heat makes the oceans even hotter, which creates even more water vapor, which traps even more heat. Once this process starts, there's no stopping it. It becomes a self-reinforcing cycle of destruction that wouldn't end until every last drop of ocean water had been converted to steam. Scientists estimate that the final surface temperatures would reach around 1,000 degrees Celsius, hot enough to melt lead and turn our planet into a molten nightmare. To put this in perspective, we're talking about temperatures that are nearly twice as hot as Venus, which already holds the record as the most hellish planet in our solar system. Venus likely experienced exactly this scenario billions of years ago, and today its surface temperature sits at a balmy 460 degrees Celsius with atmospheric pressure 90 times greater than Earth's, end quote. The energy required to actually boil away Earth's entire ocean would be absolutely staggering. We're talking about enough energy to vaporize over 1.3 billion cubic kilometers of water. That's roughly equivalent to the energy output of our sun for several days, concentrated entirely on heating our oceans. But here's the truly mind-bending part. Even if we somehow managed to supply all that energy and boil away the oceans, we still wouldn't be done. Remember all that salt? As the last bits of water evaporate, those salts would crystallize and fight desperately to hold onto the remaining water molecules. Some estimates suggest that up to 15% of the mass of dried sea salt would still contain water locked away in crystal structures. The timeline for this oceanic apocalypse would be surprisingly swift once it began. Unlike the gradual climate changes we worry about today, a runaway greenhouse effect moves with terrifying speed. Within just a few decades, the process would become irreversible. The first signs would be coastal regions experiencing temperatures that make the hottest desert seem pleasant by comparison. As the water vapor accumulates in our atmosphere, something fascinating yet horrifying would happen to our planet's radiation balance. Earth normally cools itself by radiating heat back into space, but all that atmospheric water vapor would act like a massive blanket, trapping thermal radiation. The planet would essentially lose its ability to cool down, no matter what we tried to do about it. The biological consequences would be immediate and absolute. Every living thing on Earth depends on liquid water to survive, and we're not just talking about ocean creatures here. The entire water cycle that supports all terrestrial life would collapse. Rivers, lakes, groundwater, everything would eventually join the atmospheric steam bath. Plants would wither and die within days as soil moisture evaporated. Animals would follow shortly after, unable to find any source of drinkable water anywhere on the planet. But here's where the physics gets truly wild. As our atmosphere becomes saturated with water vapor, the very structure of our planet's weather systems would completely break down. Imagine hurricanes that make Category 5 storms look like gentle breezes. Except these wouldn't be carrying liquid water, they'd be swirling masses of superheated steam, moving at incredible speeds across a landscape that's slowly turning into molten rock. The atmospheric pressure would skyrocket as all that vaporized ocean water piles up overhead. We're talking about pressures that would crush anything trying to survive on the surface. Your ears wouldn't just pop, your entire body would be compressed by an atmosphere that's become unimaginably dense and heavy. Now, You might be wondering whether human activities could actually trigger this nightmare scenario. The short answer is probably not, and that's genuinely good news for once. Scientists have calculated that it would take atmospheric carbon dioxide levels of around 30,000 parts per million to potentially kick off this process. Current levels sit at about 420 parts per million, meaning we'd need more than 70 times as much CO2 into our atmosphere. Even our most extreme climate change projections don't come close to reaching those levels through fossil fuel emissions alone. But that doesn't mean we're completely safe. A massive asteroid impact, supervolcanic eruption, or dramatic increase in solar radiation could potentially provide the initial energy needed to start the process. The most chilling part about this scenario is its permanence. Once a planet experiences a complete runaway greenhouse effect, there's no going back. The water doesn't just disappear temporarily, it's lost to space forever. High in the atmosphere, ultraviolet radiation from the sun would split water molecules into hydrogen and oxygen. The lightweight hydrogen would escape into space, while the oxygen would either escape as well or react with surface materials. This is exactly what scientists believe happened to Venus billions of years ago, leaving behind only trace amounts of water vapor in an atmosphere that's now 96% carbon dioxide. So there you have it. Your question about boiling away Earth's oceans reveals one of the most extreme planetary catastrophes imaginable. We'd need temperatures exceeding 1,000 degrees Celsius, energy equivalent to several days of our sun's total output, and we'd trigger an unstoppable runaway greenhouse effect that would transform our blue marble into a hellish steam-covered wasteland hotter than Venus. The good news? Current human activities aren't even close to capable of triggering this nightmare. We'd need carbon dioxide levels more than 70 times higher than what we have today. The bad news? Once this process starts from any cause, whether it's a massive asteroid, supervolcanic eruption, or dramatic solar changes, there's absolutely no stopping it. The water would be lost to space forever, just like what happened to Venus billions of years ago. It's a sobering reminder of just how delicate the balance is that keeps our planet habitable. Those vast blue oceans that seem so permanent and unchanging, they're actually hanging onto our world by the thinnest of physical threads. Sometimes the most terrifying scenarios help us appreciate just how miraculous our everyday existence really is.